Now we're going to set our sights on solving some equations. The first kind of equation we're going to solve is an exponential equation, which means x is in the exponent. And these first couple, x is going to be in the exponent on both sides of our equation. Trick to doing this is hopefully pretty simple at first. So if I have an equation like this, 3 raised to the x minus 2 power equals 3 raised to the 3x plus 4 power. Well, I don't think it takes rocket science to figure out that if I have 3 to a power equals 3 to a power, those powers should probably be the same thing, right? So if I'm able to equate or have the same base for the powers, what I can do is I can equate the exponents. Meaning, if it's the same base, the exponents better equal each other. I'll just ignore the bases and take x minus 2 and set it equal to 3x plus 4, and then solve it like I would any other basic linear equation. Well, let's solve for x. I would probably subtract x from both sides, because I like to keep x positive, and then I'd subtract the 4 to get the constants together on one side or the other. My left side is negative 6, my right side is 2x. Last step to solve for x is to divide both sides by 2, so x must equal negative 3. Plug it back in and check it out. I'd have 3 to the negative 5th over here. On this side, negative 3 times 3 is negative 9, plus 4 is also negative 5. So 3 to the negative 5th equals 3 to the negative 5th. That's true. Negative 3 is our answer. Things might get slightly more difficult if I don't see the same base. So with this equation, I've got 9 raised to a power and 27 raised to a power. Well, in this case, I don't see the same base. But maybe with a little bit of trickery and magic, I could change the expressions so that they have the same base. I'll show you what I mean. I know that 9 is a power of 3, and I know that 27 is also a power of 3. So what I'm going to do is I'm going to change this 9 into 3 squared. Okay? And I'm going to change the 27 into 3 cubed. So now these equations are both written with bases of 3. Well, 3 squared, or 9, was raised to the 2x power. Over here, 3 cubed, which is the same as 27, was raised to the x minus 1 power. Now, as I look at these expressions, I notice parentheses. I'm going to look to simplify using some powers or properties of exponents. When I have a power raised to another power, I multiply the exponents together. So I'll take 2 times 2x and rewrite that as 4x. So on one side I have 3 to the 4x. Over here, I multiply these exponents together. I take the 3 times x minus 1, the whole thing, which means I really need to distribute, and that'll turn into 3x minus 3. Now that I have the same base on both sides, I'll do like I did before and equate the exponents. If these have the same base, then their exponents have to equal each other as well. So I could write 4x is equal to 3x minus 3, and then solve for x. Well, let's get the x's together on one side. That happens to turn into x equals negative 3, the same answer we got to the other equation. Again, coincidence only, but works out just fine. So that would be solving exponential equations where there's x's on both sides. Try to get the same base, equate the exponents, and solve.